All right, we're back. We're on page 7 of notes 5 of the Calc AB Notes. We're talking mean value theorem. And this problem is going to have a lot going on. So the function f of x satisfies the conditions of the mean value theorem on the interval from 5 to 12. Okay, so we're dealing with the interval from 5 to 12. That's how I read that. And I wrote it, so that's definitely how you should read it. And x equals 8 and x equals 11 are the values of x whose existence are guaranteed by the mean value theorem. So we know two things kind of based on that. We know that from number 1 here, so number 1 is basically saying that f prime of 8 is equal to f prime of 11, right? Because if they're both parallel to the secant line, they must be parallel to each other, so they must have the same value. So f prime of 8 equals f prime of 11. And then both of those are equal to f of 12 minus f of 5 over 12 minus 5. This is I don't know if this is going to be useful, but that's what that's saying. Now, number 2 says f of 5 is 6, f of 8 is negative. It's just a bunch of things. F of 8 is negative 3, f of 11 is 7, f prime of 8 is 4. So what's that telling us? That's telling us, number 2, is telling us that all of this stuff, I don't know how to indicate this, is equal to 4. Because we are told that f prime of 8 is 4, which means f prime of 11 is 4, which means f of 12 minus f of 5 over 12 minus 5 is 4. So we know a lot of stuff there. We also know those other random values, which will probably be useful. The tangent line to f of x at x equals 11 intersects f of x again at x equals 4. I don't know. Well, we'll see how that goes. So what can we do? First question. Write the equation line tangent. Okay, so I need to know f of 11, which I do know. That's in number 2 there. So f of 11, what? F of 11 equals 7. And we need f prime of 11, but if I remember correctly, we said by our chain of logic that f prime of 11 is equal to 4. So we have both of those. So that means that our tangent line is going to be y minus the y value is the slope, and then x minus 11. And that's it, I think. Okay. So now find f of 12. All right. Well, let's go back to our thing here that would, this turns out to, this is a fruitful find that we have here. So we actually know that f of 12 minus f of 5 over 12 minus 5 is equal to 4. So we know that. And then if you look at the given information, we know that f of 5 equals 6. So I'm doing this problem here, using all that information. So f of 12 minus f of 5 over 12 minus 5. Let's write it again. F of 12 minus f of 5 over 12 minus 5 equals 4. And then f of 5 is 6. So that's f of 12 minus 6 over 7, right? 12 minus 5 is 7, equals 4. So let's go up here, and we'll say that f of 12 is equal to 28 plus 6, 34, I think. I'm going to go with that as my final answer. I think that's our answer. All right. What's the next piece of information? Find f of 4. Okay, so if you look at the given information, the only times that you see 4 are when it's f prime of 8 equals 4, but that's not important because that's an x value. And then in number 3, the tangent line to f of x at x equals 11 intersects f of x again at x equals 4. So the tangent line intersects the curve. So if we were to draw something for this, maybe we would draw it doesn't need to be perfect, but so maybe like this, and then we would have our tangent line here at, well, actually, I guess let me just draw. So there's our tangent line. So this, I guess, would be x equals 11. It intersects again. That's not a tangent line, but this is the basic idea, right? I would have to put too much thought into it to make the picture look really good. Really, it should be the reverse. It should be like 11 should be where 4 is and 4 should be where 11 is, but that doesn't make any sense. Anyway, what I'm saying is if I plug 4 into the equation of the tangent line, I should get what I'm looking for. So to do this problem, I'm going to use this tangent line and plug in 4. So so f of 4. F of 4 is actually equal to 7 plus 4 times 4 minus 11, I guess, which is, what is that? I think it's negative 21. So 7 minus 28. I don't know where I'm getting that. Oh, 4 minus 11 is negative 7 times 4 is negative 28. So yeah, f of 4 is negative 20. I'm pretty sure f of 4 is negative 21. This is a tricky question. It's got a lot of like little nuances to it. Nothing too complicated, but like, I don't know. Find f prime of 5 or explain why it can't be found from what we know. So I can find f of 5, or I know f of 5. I know the slope of the secant line through it. I know the slope at some tangent lines. There's just not enough information. So f prime of 5 cannot be found. And how do I justify that? F prime of 5 cannot be found. Not enough info. So I can explain to you why I wrote this question. A lot of people accidentally think that the slope at the endpoints, like where the secant line is determined, they think that the slope of the tangent line at those points sometimes is equal to the slope of the secant line, which doesn't really make any sense. But it's a really popular misconception. And so I wrote this problem just to like make everyone think about it for a second. We know f of 5, we know f of 12. We don't know f prime of 5 or f prime of 12, it turns out. We know a lot of other stuff, but not that. So let's see. Given that f prime of, well, now we know f prime of 12. Given that f prime of 12 equals negative 3, find where the line tangent to f of x at 12 intersects the line tangent to f of x at 8. Okay. Okay, so what do we know here? We know, what colors have I used? All right, we know this. And then do we know f of 12? Somehow? Oh, f of 12 we solved for. So f of 12 is 34. So let's write that tangent line. So tangent at x equals 12. So y minus 34 is negative 3x minus 12. Okay. And then I need the tangent line at x equals 8. So the tangent at x equals 8. I don't need to solve a system. Like, come on. All right, so we're just given f of 8 is negative 3 and f prime is 4. So we're good to go. F of 8 is negative 3. F prime of 8 is 4. So our tangent line is y plus 3 is 4, x minus 8. Okay, so I don't know how we want to solve this. I'm going to set them both equal to y and set them equal to each other, I guess. So negative 34 minus 3x minus 12 is equal to negative 3 plus 4 x minus 8. You do a lot of like algebra 1 in calculus, which is really interesting to me because like everyone's always like, let's get to calculus, and then you get there and you're like, let's do algebra 1. Negative 31 is, all right, I'm gonna like move, so 7x, right? Because on the right hand side I have 4x, on the left I have negative 3x, bring it over 7x. On the right hand side I have negative 32. On the left hand side I have positive 36. I'm gonna bring that over and get negative 32 minus 36, negative 68. This is looking like a great answer. And then, so x is going to be add 68, you get 37. 37 over 7? and then I'm supposed to find the y coordinate. This is terrible. You know what I'm gonna do? I'm gonna check it on the calculator, and really that's me saying that I'm gonna use the calculator to find the y value. But you know, it's all good. Solve. Y minus 34 equals -3. So I should do solve system because it's easier for you guys. Menu, 3, 7, solve system, 2 equations, 2 unknowns. Y minus 34 equals -3, x minus 12, and then y plus 3 equals 4, x minus 8. Boom, 15. 15. There's clearly a problem. But the problem is in my algebra, I guess. So let's go back and see. I get 15 and 25. That's very different from what I got. So maybe I shouldn't have skipped like every step I could skip. Let's find the problem. All right, so, oh, I found the problem. It's not -34, it's positive 34. Crud. This is positive 34. What else can we save? Pretty much nothing, I'm guessing. So then this becomes 37. Add the 3, becomes 37. And then it's kind of hard to believe that this would work out, but let's see. So 37 and 68 is 90. It's 105 over 7. Oh yeah, which is 15. Look at that. We got it eventually. And then I'm pretty sure, well, 15 isn't so bad to plug in. So y would be, I'm going to use the bottom one, -3 plus 4 times 7, so 25. All right, so our intersection point is 15, 25, but I did not get it right the first time, and I'm going to say that that's okay because that happens in life. Is this the last part? It is. All right. So far, so good. Well, so far, mostly good, although I would have gotten the x coordinate wrong and then the y coordinate. But I kind of like, you don't know, but I definitely didn't want to plug in that x coordinate. So at that point, I was like, let's go to the calculator and see. Find the area of the region enclosed by the line tangent to f at 12 and the x and y axes. So the tangent at 12, we have, that's this. And the x and y axes. Okay, so it's let's rewrite this in point slope form. Point slope? No, slope intercept. You know, I use point slope so often that it's my go-to name for a line. So this will be -3x, and then it's plus 36 plus 34 plus 70. Okay, so why would we do this? Well, we'll see later on that finding areas of regions is kind of a big deal. And so we want to be good at it like as soon as possible. So it's a triangle. So the area is going to be 1/2 the base, which is 70 over 3, and the height, which is 70. So that's going to be 49, 2 zeros, over 6. Do we want to simplify that? I don't, but 2450 over 3, and then 2, 4, and 5 is not divisible. So let's say 2450 over 3. That's the area. So let's say units squared. All right, I'm going to call it a day on this video, and I will come back in the next video and do even more. So I will see you then.